Good afternoon, everyone, and thank you for joining us for our next session in the Signal Innovation Showcase series. Our next speaker is Dr. James Matney, Senior Vice President of Technology with MSM Technology, and he's going to be talking to us about transforming DevSecOps. So please welcome James to the podium.
All right, good afternoon, everybody. And I did my best to try to draw people in because, we put the wine and the drinks right there. But still, I want to thank you for being here. But before I start, how many people here know Garrett Yee? Right? Well, how many people remember him whenever he would have, speaking engagements? He would call out different people because they said they would be here. Well, when you see Garrett, make sure you tell him, say, Jim Matney called him out because he told me he would be here. But no, I tell you, it's an exciting event. I tell you, I'm super happy to be here, and we're going to talk about DevSecOps here. But before I start, how many developers do we have, like actual developers that's coded at some time in their career? All right, very good. Which is really good because as we walk through, and this morning in one of the very first sessions, Jeff Marshall, he came up. He has this different quotes that he ends up having for the marketing piece, which one of them, which I thought resonated well with how we're going to talk about today, which is why before what. We heard that this morning, right? I thought that was very good, and it's really relevant, especially when you look at this next slide right here. Those who are developers, who recognizes each of these models, right? See, good, I'm not the only one. So I wish I could say this is an evolution, but it's not really an evolution because there's a lot of organizations that's still using these today. Even though DevOps was created over 15 years ago and DevSecOps over 5 years ago, organizations are using all three of these here. So what I want to do is just highlight them for those who aren't too familiar with these. Waterfall model, that's the development where it's actually rigid, very sequential in its operations. It goes from, see what happens when you hit the next button? Right? It's between the, it actually causes significant delays in the implementation of this because when issues are found, it's a lot of rework that has to happen associated with this. Well, DevOps actually did a lot to fix these issues, and what they did was they shifted left operations. They injected operations into the life cycle and had it for where it was a lot smaller chunks, so it wasn't just these huge releases like in a big bang approach, where it was multiple releases that enabled you to be able to go through this iterative cycle of being able to do the build, test, and deploy operations. Now, one of that piece, that first bullet you see there for DevOps is the continuous integration and continuous delivery. Now that I think was the major aspect of this because what that ended up doing was it injected automation into this. So now you have it where you can automate those builds, you can automate the different types of tests that were going on, and also the deployment of it. So that enabled users to receive some of the capability and return on investment for this whatever program, so you can be able to meet the needs of the customer. Now, DevSecOps, it did what DevOps was doing. What it did was it shifted left security. So where it embedded security in each of the different phases and actually applying zero trust principles as they went through this to make sure that security wasn't just implemented as a part of a testing cycle, that it was actually implemented as part of the entire life cycle throughout. And I'll talk about more of this in a little bit. But here for the next 2 slides, I'm going to talk about the issues. Specifically, I'm going to walk down each one. Because with the waterfall, it's important to understand, the why before what, right? We had the waterfall method. And with this, you look at the flow that it went through, you analyzed the requirements, you did the systems design, you coded, you tested, you deployed, you maintained it. Makes sense, right? Well, that was an actual method that was used for many years until we came up with this iterative approach, with DevOps and then DevSecOps. But what were the issues that's associated with this? Well, security with the testing was done too late, as I mentioned previously. For instance, discovering a SQL injection vulnerability during the testing phase would require a complete rewrite of the code. So with having SQL injections is where, how many of you have written SQL statements as you're designing code, and then you're actually pulling in a user's input? Well, a SQL injection is when that user actually puts in something to alter your SQL statement, and then actually can either give themselves access or have access to additional data that they weren't intended to have access to. So that type of vulnerability, if you designed your database system without taking that into account, that can require significant rework that delays schedules and increases cost. As a retired Air Force comm officer, I had the pleasure of working the Cheyenne Mountain Upgrade, which is a project back in the mid-90s. And when you follow this life cycle, requirements were analyzed in the first phase, which, most back then, that's how everything starts with the requirement analysis. But then once it was analyzed, it went into a job jar. And then once it was in a job jar, it waited there until it was assigned a version release. And then once it was assigned a version release, it bubbled up to be one of the priorities in the next version release. It kicked off a more than 12-month cycle before that version release would be deployed. That's if everything went smoothly. So you can imagine, the responsiveness to user needs just wasn't there when it came to programs, following this life cycle, especially with the Cheyenne Mountain upgrade. Some of the requirements that were in that the job jar in that first phase, they actually stayed there for years because they never reached a high enough priority to make it into a version release. A couple other examples are with the VA and Air Force. The VA's electronic health records system and also the Air Force's account management system project, they used the waterfall method and had similar issues as CMU, the Cheyenne Mountain upgrade. They had schedule delays, budget overruns due to the inability to adapt to project complexities, but then also with the evolving requirements. Now let's look at DevOps. As I mentioned, DevOps was designed to fix a lot of these issues, and actually, in many cases, it did. It solved the operations side because it shifted left operations. But even though it enhanced the collaboration between the operations teams and the developers, and it also leveraged automation in the CI/CD pipelines, the issues regarding security were still there because it was still late in the life cycle. So a couple of the ones here that I want to be able to highlight was, one is that security was often treated as an afterthought, which resulted in vulnerabilities being discovered too late. The lack of uniform security practices, that created challenges in meeting security compliance, but then also in achieving ATOs. But the third one is the one that I think is the most significant, because as you have this DevOps process and you have this continuous deployment of new capabilities, what is that doing to your approved ATO, right? Most of them are considered a major change to the baseline, which means you have to do what? Reaccredit the system. So that reaccreditation process is something that is lengthy and oftentimes fell behind the CI/CD pipeline as it's being deployed. So these examples that when you look at the different challenges that's associated with DevOps, it isn't just with, like mine or any of the ones here that were in development. Again, the VA and the Air Force, they had challenges with programs too. The VA's IT modernization project, they had issues with integrating legacy systems. And I'm sure many organizations experienced those as well. And then the Air Force had Kessel Run. Who's familiar with Kessel Run, right? Kessel Run, it faced delays because of security issues, but more importantly because the challenges associated with integrating all of the DevOps tools. The DevOps tools and the complexities, because they weren't designed to interface with and work well with each other, so their challenges associated with that is something that actually they worked really hard to overcome. Now, I'm not picking on the VA and the Air Force with these examples. When you're leaders in industry, you're going to face challenges that others haven't faced. And with their desire, their aim as they end up embracing, a DevOps type implementations, was to be able to provide better capabilities to the warfighter faster, in a more secure way, right? So when it comes to these, it really looks at, as the next slide I go into, they also had success when it comes to this next method, which is what we're here about, which is DevSecOps. Now, I wish I could take credit for the representation of DevSecOps on the top right of the screen, but that actually is DISA's representation. And I've seen quite a few different drawings associated, trying to portray DevSecOps. This is the one I consider the best, right? It really integrates DevSec and Ops into a workflow. For where most other instances I've seen, for where they actually use the DevOps cycle and they just put security at the top. Well, that's outside the infinity diagram, which means really it's a bolt-on. But this representation, I think, truly, really believe it's the best. But in a similar fashion that DevOps shifted left operations, as I mentioned, DevSecOps focused on security, implementing security at every stage. The goal here is to catch security issues sooner so we can prevent the vulnerabilities from making their way into production. And they also enhance the CI/CD pipeline, because where DevOps automated the build, test, deploy, DevSecOps automates the security testing in every phase. So you're able to do all those pen tests and the SAST and DAST type testings. And then what you see across the bottom of the screen is the 7 pillars of zero trust. Do everybody recognize those? I know there was a lot of briefings talking about those. What I tried to do is be able to have it where there's a couple bullets to show how DevSecOps actually interfaces with each of those pillars. And I'm not going to go over all of them, I'll just touch on 3 of them. We'll start with user verification. In addition to ICAM, which, how many heard Randy Resnick refer to ICAM as the source of truth for zero trust, right? In addition to ICAM, you have the PRMFA, which is phishing resistant multi-factor authentication, but then also least privilege access. Both of these ensure that the only authorized and authenticated users have access to the critical resources. And in the middle, the application workload protection, that's where the developers actually really earn their money. If you're a developer, this is where you have it. I mean, what DevSecOps does here is it employs secure coding practices, as well as automated security checks, but then also there's something called immutable workloads. How many people understand immutability? Right? See, developers, right? I'll talk about that a little bit more in a minute. And then on the right side, with visibility and analytics, with all of this automation, and you have the continuous monitoring, you're able to enhance and gain deeper insights into what's going on in that development process at any stage, right? Now, I talked about the challenges that the VA and Air Force had with the other methods. Now, let me give you a couple good examples here. The VA integrated DevSecOps into their veteran-focused integrated process, which is called the VIP framework. And the Air Force, what did the Air Force do? Anybody? They created Platform One, which is a centralized DevSecOps environment that enables CI/CD pipelines and also agile practices. So, you're an organization, you want to be able to develop software, write a program. How do you get started? Well, back in acquisition training when I was in uniform, there was a big statement we would always say, which was, well, it depends. Well, that's really true here as well, because it's like, where are you? Are you using a waterfall method? If so, then you need to be able to employ the shift left operations and shift left security. If you already have a robust DevOps practice where you've shifted left operations already, where they're engaged throughout their life cycle, then the focus can be on the security side. You have to shift left security. So the points that I'm making here is, regardless of which ones that you're going from, the focus really should be on immutability and automation. The immutability ensures a system and components are unchangeable once deployed. And you do this through adopting infrastructure as code, and also creating and managing application artifacts, like containers, VM images, and deployment packages, but then also using a robust version control system, right? And you can validate this immutability by leveraging tools as well, because essentially what it does is, I guess if I were to explain immutability, is you take an image and it creates a hash. You create a hash of an image, then you just compare the hashes. If there's a difference, that means something's happened and changed that. You just replace that image, right? So instead of trying to figure out what happened to the security or if a hacker got into that application itself, you're able to replace that code with a new version of the original version that is a trusted version, and then just be able to have that established hash, and you use the tools to be able to compare that hash. A couple of the tools is like the ELK stack, which is Elasticsearch, Logstash, and Kibana. Those 3 you can use to be able to help make sure that your software, your programs are consistent and secure. The other area of focus is automation. And I want to touch on this just a bit because emphasizing automation, I spoke about automation, automating the build, test, deploy, and you automate the security throughout. But where automation also is important, especially in today's day and age with AI. Well, it's hard to say automation without thinking AI. Now AI is actually going into the design side. But one thing, and I just want to touch on just a second, is that we've got to make sure that we're using caution when we leverage AI to take folks who aren't a developer, who understand what good code looks like and what it means to design good code, then that means we need to be able to, we can leverage that AI to create efficiencies, but we must be able to check that code and make sure that it's doing exactly what you want it to be able to do. Now, the other, what you see down at the bottom, is there's a couple platforms that are already out there. You have DISA's, DevSecOps platform, where they integrated, two programs. They have Vulkan and then Citadel. Vulkan is your adaptive tool chain, and then Citadel is their software factory, which is really their DevSecOps platform. And then you have Platform One, which again, it seems like all the DevSecOps platforms have cool names. You got Platform One as Iron Bank, Big Bang, and Party Bus, right? Where you're leveraging, you have your DoD repository of approved container images. Big Bang is your infrastructure as code, so you can automatically create your environment in a secure manner. And then your Party Bus is really your DevSecOps platform, that platform as a service that the Air Force offers in that centralized environment. Now for the transformative structure, this MSM, we have a cyber-resistant DevSecOps approach that we take. And really the 2 points that I want to be able to make on here is where we focus on cyber resiliency. Cyber resiliency and also user centricity. Our user-centric design approach includes continuous feedback loops, and that ensures that there's higher user satisfaction. But then also with cyber resiliency, our goal is to make sure our DevSecOps platform is resilient regardless of the emerging threats like quantum computing, had to throw quantum in there, and also the changing environments. Now, changing environments isn't just technical. How many saw the software fast track program SWIFT that the DoD CIO just released? That program is going to actually transform the way that ATOs, specifically the RMF framework, is processed, is handled, right? Regardless of these changes, it doesn't change our warfighters' need to have trust in the confidentiality, integrity, and availability of all their mission-critical systems, regardless of the framework being used that ensures they're secure. Now, selecting target programs. Oops. Sorry. Okay, it just got locked up on me. Sorry. Oh, there you go. The couple points to note here is that, just want to be able to highlight is, start with an initial pilot. You see my recommendations there, but I just want to touch on COTS GOTS applications. Even though COTS and GOTS, which is commercial off the shelf and government off the shelf, they're not typical software programs, but they can benefit from DevSecOps. And in the manner in which they do that is where you still need to be able to leverage immutability when you deploy them. Because with COTS, you still got to develop, you still have to design which capabilities you're going to actually configure the COTS products to, but then also immutability for being able to deploy it in a secure fashion. And then these are just a couple of recommendations that we have through here. And as I mentioned before, the shift left operations and shift left security. You got to keep both of those in mind when you're employing, a DevSecOps capability, but then also use an existing platform that's out there. DISA's DevSecOps platform is robust. It's very good, and with their adaptive tool chain can be used in others' environments. But then also with the Air Force's Platform One, that's a very proven capability that you're able to leverage the actual infrastructure as code to build your environment, as well as approved different, with the repository of secure hardened images, right? And in closing, right? I want to say that, with DevSecOps, it's not just the latest name. It really has been transformed over the years from a waterfall method to a DevOps to DevSecOps, where the need for shifting left operations and also shifting left security is there. And we need to make sure that as we're implementing and designing software, we're taking that into account, but then also being able to be adaptive to the changing environment to make sure that we can handle the emerging threats. That concludes my presentation, and thank you for your attendance, especially this time of day. If there's any questions, please see us at our booth at 3039. Thank you.
Thank you, Dr. Matney. That was great. Thank you all for being here. It's always great to see you. And please join us again in 10 minutes for our next presentation. Thank you.